Kant says, I had to deny knowledge in order to make room for faith. Kant found that he needed to broach some very basic questions about the scope and limits of our knowledge, what we could know, how much we could know, and what that might mean for what we could not know. How is it possible, just sitting in an armchair, to know what space is like? Why don't we have to go out and investigate? Asks Kant. The only answer that he thought he could give was, well, this must be because space is somehow dependent on us. Space and time as well, for that matter, are a little bit like native spectacles that we carry around with us, that this is how we view things. It's as if we impose a structure onto what we see when we look out at the world. And this structure includes space and time themselves. And he thought that things in space and time were therefore mere appearances. There's this underlying reality that is not spatial and is not temporal, but we can't know what that's like because we can't take our spectacles off. Kant is now telling us something very fundamental about the scope and the limits of our knowledge. We're limited to knowing what things in space and time are like. And what that means is we're limited to knowing what appearances are like. We can't know how things in themselves are. And this is all very relevant to his ethics, because he believes that our freedom is a matter of how we are in reality, not a matter of how we appear. And that's why even our freedom goes beyond the bounds of our knowledge.
Hey guys, welcome to another episode of Wandering Thoughts. Today I'm with Professor Adrian Moore. Professor, thanks for joining us. It's a pleasure to be talking to you and thank you for your time. I think it's good to start by just telling us a little bit about yourself.
First of all, thank you very much for the invitation to participate in this podcast. I appreciate it. I am, for a little while longer, Professor of Philosophy at the University of Oxford. I say for a little while longer, simply because this is my last year before retirement. I'm going to be retiring at the end of this academic year, but that's my current position, and I've been here for nearly 40 years. I have a range of philosophical interests. I often describe myself as a philosophical generalist. That's the complimentary way to put it. A somewhat more derogatory way to put it would be to say a jack of all trades and master of none. But I do have a range of philosophical interests and try to see what the various connections are between the different parts of philosophy that I'm studying. Metaphysics, philosophy of mathematics, philosophy of language, ethics, philosophy of religion. All of these have always been of interest to me. And there are particular philosophers that I've spent quite a bit of time thinking about and working on as well. And I guess the two philosophers that I've spent most time working on and that have been most influential on me are Kant and Wittgenstein. Each of those has exercised quite a significant influence on me, and some of my work has been concerned with teasing out connections between them. looking at ways in which we can study Kant in the light of Wittgenstein and ways in which we can study Wittgenstein in the light of Kant.
That's really interesting. So there's a lot of topics, and usually when I have a conversation with other scholars, I usually have a lot of questions to ask them, but they're always surrounded within certain topics. For instance, I had James York on recently, who coined the term chaos in math. And I had a lot of questions, but it was around chaos theory mainly. And with you, I thought, oh God, I have so many questions on so many different topics. So I think perhaps a good idea would be to take them one by one and do our best to make have a good introduction to these topics, and then perhaps try to identify their connections too. So I think a good point to start would be when it comes to metaphysics. I think the fundamental question for listeners who might have not have heard of philosophy and what philosophy is, maybe let's start with what philosophy is, and then what aspect of philosophy does metaphysics spend time on thinking about.
Good. Yes, I have a definition of metaphysics that I personally have found quite helpful and have used as a guide to my work in metaphysics, which is the most general attempt to make sense of things. And as I say, that's a definition that has been quite prominent in some of my work, and that I've found provides a useful framework. But you actually asked what my definition of philosophy was, and how metaphysics in particular might be distinguished from the rest of philosophy, from other branches of philosophy. And actually, I'm inclined to wheel out the same definition to some extent, and to think of it as to think of metaphysics as differing from other branches of philosophy by degree rather than by kind. So there is a sense in which, if you ask me what philosophy was, I'd be inclined to give, maybe the same answer or a very similar answer, a very general attempt to make sense of things. And then metaphysics is perhaps distinguished by its sheer generality, the most general attempt to make sense of things. So when you're operating at an incredibly high level of generality, and are just interested in fundamental questions about the structure of reality, the relationship between the mind and what lies outside the mind, whether there's any sense in which mind is more fundamental than matter, whether there's any sense in which matter is more fundamental than mind. Highly abstract questions of this kind. Scientists are concerned with making sense of reality, of things as well. But I guess my view is that they're not typically operating at quite the same high level of generality. I mean, sometimes they are really. Abstract physics is operating at a very high level of generality, but never quite at the same high level of generality as metaphysics. And I think that's part of the explanation for why scientists need to, as it were, go out and get their hands dirty do experiments and appeal to observations, find out by empirical means what the world is like, whereas philosophy is a discipline that can be conducted in the armchair. You are able to just think about these issues in very abstract terms. And admittedly, that's one of the things that makes people suspicious of philosophy in general and metaphysics in particular. But those of us who are philosophers and those of us that have an interest in metaphysics think that there is still a worthwhile exercise of that kind that you can conduct.
Interesting. Yeah, I'm happy you brought up science in the conversation, because I was planning to ask you what the difference of studying science is with the difference of studying philosophy. I wonder, what's the main issues in metaphysics that have interested you over the years? I know you've written a book, The Evolution of Metaphysics, so I would love to understand it in a chronological scale, how from perhaps, I don't know where we start with metaphysics, how many thousands of years ago?
Well, perhaps I can say a little bit about that book and maybe use that as a way of answering your question. You're right that I wrote a book entitled The Evolution of Modern Metaphysics, and it was commissioned. I was invited to write this book for a series. And what that meant was that to some extent to a considerable extent, I was constrained in what the book would look like, because it had to conform to the outline of the series as a whole. I mean, as it happened, it was a welcome constraint, and I was more than happy to work within that framework, but it was dictated. And there are two things in particular that are significant about that. One is that those of us that were contributing to the series were told that our historical study only had to go back as far as the beginning of what's known as the modern era, the point at which scholasticism gave way to modern philosophy, typically thought to coincide with the point at which Descartes entered the scene. So although you're absolutely right that philosophy in general and metaphysics in particular are thousands of years old, my historical study only goes back 400 years or so. But the other thing that was significant about this series was each of us was invited to focus on a particular branch of philosophy. And in my case, obviously it was metaphysics, but not with a view to sketching a history of contributions that people had made to that branch of philosophy, but rather with a view to sketching a history of how people had conceived that branch of philosophy, what they thought about it, what they thought they were doing. So my book is a kind of history of metaphysics rather than metaphysics. What is the nature of the enterprise? What have people thought they were doing? Or for that matter, what have people thought they were reacting against? Because very, very often the word metaphysics is used as a derogatory term. People have used it to serve as a label for something that they thought was illegitimate. and they've wanted to distinguish between what they were doing and what they call metaphysics. So my book is operating at a really high level of generality. I mean, metaphysics itself, as I say, is already very general, but here I am stepping up yet another level and asking questions about the nature of metaphysics. So it does mean that in the book itself, I didn't really have as much opportunity as I might have done in another book to explore first order issues about the various metaphysical questions that arise and the sorts of things that I might be in particular interested in. But one thing that I tried to argue in the book is that there is scope in metaphysics for a kind of creativity, that it is possible for metaphysicians to be creative in the same way that artists are, by giving us new ways of making sense of things, new concepts to exercise, new concepts that perhaps even that we can direct our lives by. I suppose the thing that really excites me when it's done really well, is the kind of metaphysics that is creative and innovative in that way, and is operating at a very high level of generality, but that does also have practical repercussions, and can feed into ethics and can help us to think about the big questions about how we should conduct our lives and what we think really matters, and so on and so forth. And I mean, in the past, it's very, very much played that role, not least because very often the great metaphysicians of the past have also been people with quite deep religious convictions. So a lot of their work has been focused on the nature of God and the relationship between God and God's creation. And whether you're religious or not, you can see the value of that kind of work. If you are religious, you will think that that's already an example of the kind of metaphysics that has practical repercussions. If you're not religious, you might nevertheless be interested in the possibility of a kind of secular alternative to that sort of work. And so that's the kind of thing um, that I personally find exciting and interesting in metaphysics.
So you find exciting when metaphysics give us some kind of clue on how to behave in our lives and
Yeah.
have these innovative aspects. And interesting. So you focused on the last 400 years then, starting from around Descartes and coming to the present. Can you talk to us a little bit about what you've learned from studying all this period of time, and perhaps explain to us so we can put it in a almost chronological map, what the primary figures were from that time to now?
Yeah. Well, the book is divided into three sections, and it's not completely chronological. It's partly chronological, but not completely. So let me explain what I mean by that. I'm basically covering a period of 4 centuries, 17th, 18th, and 19th and 20th centuries. And the first part is concerned with the first 2 centuries, the 17th and the 18th, spilling over slightly into the 19th century. But then parts 2 and 3 are both concerned with the 19th and 20th century. And what distinguishes them is a distinction that philosophers often draw these days between what's often called analytic philosophy, on the one hand, and then on the other hand, various non-analytic traditions. So I devote part 2 to what's called analytic philosophy, which is reckoned to be a comparatively recent development in philosophy, with its origins going back to the late 19th century, early 20th century. And then in part 3, go back over the same period, but looking at these other traditions instead. One of the things that emerges is that there are recurring patterns, and quite often philosophers set themselves up in opposition to one another. So this distinction that I've just mentioned between analytic philosophy and non-analytic philosophy is often presented almost as if there were these 2 fronts in some kind of opposition to each other. And one of the things that I tried to do in my book, partly by tracing the story in the 19th and 20th century twice, going through it, first of all, from an analytic point of view and then from a non-analytic point of view. One of the things that I was keen to do was to show that we should get away from the idea that there's opposition between these various traditions. There are different traditions, and philosophers are coming at things in their own various different ways. But it's a crude oversimplification to think of this in terms of opposition. And very often, it seems to me, what's going on is that different philosophers are saying very, very similar things to one another, but couched in their own different idioms and responsive to the cultural context in which they find themselves. And the differences thereby become often as interesting as the similarities, but the similarities are very interesting as well, and it can be really profitable to trace them through and to look at the links and the connections. And one thing that I think emerged for me from this exercise was that although philosophers in various different ways have been suspicious about the idea of metaphysics, again and again and again, people come along who are interested in tackling these big questions about how we make sense of things. And very often they've had the same aspiration that I said I had, which is they've tackled these big questions because they've thought that it was going to be of some practical significance, that there is actually quite an interesting and tight connection between metaphysics and ethics.
Okay, so when it comes to analytic and non-analytic philosophy, what does non-analytic philosophy break down to other subcategories? For instance, is continental philosophy an example of non-analytic philosophy? Is there more examples?
Yeah, I mean the contrast that's often drawn is between analytic philosophy and continental philosophy, and and you'll often hear people drawing the distinction in these terms. Now, the 20th century British philosopher Bernard Williams um, had a very amusing criticism of that way of drawing the distinction, which he always thought was weird because it seemed to involve distinguishing a style of philosophy from philosophy done in a particular geographical region. And he said it was a bit like classifying cars according to whether they were front-wheel drive or Japanese. Um, and um, and there is something infelicitous about that way of drawing the distinction. And part of the reason why it's infelicitous is not just that it seems a bit like a category mistake, but some of the great analytic philosophers, some of the really significant figures associated with the analytic tradition, were what we might call continental. I mean, the person that's often reckoned to have initiated analytic philosophy was a German philosopher, the German philosopher Gottlob Frege. Um, so it's already infelicitous for that reason, but it's also infelicitous for a reason that you put your finger on, which is that there is a tradition of analytic philosophy, but there's no one thing that it's contrasted with. Non-analytic traditions are traditions in the plural. There's quite a lot that's going on that wouldn't be classified as analytic philosophy. So, for example, there's the phenomenological tradition. There's what is sometimes called post-structuralism. One philosopher that I talk about in my book, and who I classify as a non-analytic philosopher, is Collingwood, who, in many respects, had a lot more in common with the analytic philosophers. I mean, he was British. He spent his most of his professional career in Oxford. He hung around with analytic philosophers. He discussed issues with them. But I classify him as a non-analytic philosopher because he was out on a bit of a limb, and it's yet another example of how the non-analytic traditions cover an incredibly wide range.
Interesting. So you mentioned Immanuel Kant as one of
Yeah.
the primary figures you've studied. I attempted and I completed my attempt of reading The Critique of Pure Reason last year. A lot of it went out over my head. I think a couple of things I was able to hold upon. Now, how much I've understood them the way they were supposed to be understood, I'm not sure. So why don't you perhaps talk to us a little bit about Kant and the primary metaphysical questions that he tackles?
Sure. Kant is a really interesting case in light of some of the things that I was just saying about the relationship between metaphysics and ethics. I mean, Kant is a really interesting case, full stop. And actually, in my own view, I mean, this is not a view that's shared by everyone, but on the other hand, it's not particularly idiosyncratic either. In my own view, Kant is the greatest philosopher of all time. And the book that you just mentioned, his Critique of Pure Reason, in my view, is the greatest philosophical work of all time. It's an extraordinary book. But here's the interesting thing about it. I mean, as you will have quickly realized, and as will have been obvious to you by the time you got to the end, this is very much a work of metaphysics, very, very demanding metaphysics. I mean, it's by no stretch of the imagination an easy read. But one thing that's crystal clear, even if nothing else is clear, is that Kant is concerned with metaphysics in that book. But it's not the book that he originally intended to write. He originally intended it to be a work of ethics. And this is why I said it was interesting in the light of what I was saying earlier. His primary motivating interests were interests in ethics. And he nevertheless felt that he had to try and get to grips with some metaphysical issues first before he could turn his attention to the ethical issues that he was really interested in. And what happened was that what was originally intended to be just some introductory sections eventually became the whole book. And that is the Critique of Pure Reason that finally emerged from this enterprise. And it was in other books that he turned his attention to ethics. And he did eventually go on to write about ethics. I mean, there's a little bit of ethics even in the Critique of Pure Reason, but it's only a little bit. And what's going on, if I can simplify, I mean, this is a really gross simplification, but obviously that's necessary in a context like this. What's going on is that Kant found that he needed to broach some very basic questions about the scope and limits of our knowledge, what we could know, how much we could know, and what that might mean for what we could not know. And the reason, I mean, one of the many, many reasons why this became significant for him was that he believed that some of the fundamental ideas that underpin ethics, and in particular the idea that we are free moral agents who can choose how to live our lives, these are ideas that are absolutely crucial, but in some ways lie beyond the bounds of our knowledge. So, in particular, although Kant himself was convinced that we are free moral agents, and although he thought that we had no choice but to believe that we're free moral agents, he also took the view that we could never really properly understand our own freedom. There's something deep and fundamental going on here that's beyond the limits of our understanding, beyond the limits of our knowledge. And he also eventually wanted to relate his ethical beliefs to various religious ideas, ideas about God and ideas about immortality, which again he thought took us beyond the limits of what we could know and beyond the limits of what we could understand. So he was adamant that human beings could never know for sure whether there was a God or not, that it was always going to be impossible to prove God's existence, and for that matter, impossible to disprove God's existence. But he didn't think that this prevented us from being able to speculate about God's existence. And there's a famous sentence in the preface to the Critique of Pure Reason where Kant says, I had to deny knowledge in order to make room for faith. So that's an indication of this connection that I have in mind. But what you find in the Critique of Pure Reason is a detailed exploration of human knowledge, what its limits are, what its how far it can reach, how far it cannot reach. And he's interested in human knowledge in general, but he's also in particular interested in the limits and scope of metaphysics, which is a particular kind of human knowledge. And he spends some of the book doing metaphysics, but he also spends quite a lot of the book upper level reflecting on the possibility of metaphysics. And this is all of crucial significance for him because it all bears on these broader issues of what we can and cannot know that is eventually going to be relevant to our ethical lives, what it is for us to be moral agents, and what that implies beyond the scope of our knowledge.
Interesting. Can you introduce us to the terms that Kant uses, such as a priori, a posteriori, phenomena, noumena, and what they have to do with space and time and our limits of knowledge and understanding?
Good. So there's a couple of contrasts that Kant draws, and it's important that it is a couple of contrasts, two contrasts. People before Kant had drawn similar distinctions, but they had always made do with just one distinction. And Kant comes along and draws two distinctions, and they are as follows. First of all, he draws a distinction between what he calls a priori knowledge and empirical knowledge. And the difference between these is that a priori knowledge is knowledge that you can obtain without getting your hands dirty. I mean, this goes back to what we were talking about earlier in connection with science. A priori knowledge is available to you in the armchair. You can just sit and reflect. And as a result of your reflection, you can arrive at a priori knowledge. Empirical knowledge is the kind of knowledge where you do actually need to go out and investigate or rely on the investigations that somebody else has done and take their word for it. So an example of a very simple example of a priori knowledge would be the knowledge that anything that's green is coloured. And you just need to reflect on what it is for something to be green and what it is for something to be coloured to see straight away that that's true. I mean, that's a trivial item of knowledge. There are examples of a priori knowledge that are much more interesting than that, but it's a nice, simple example of something that you can deduce just sitting in your armchair. All green things are coloured would count as a priori. But it would be an example of empirical knowledge that all green things reflect light of such and such a wavelength. I mean, I'm not a physicist. I don't know what the details are, but, imagine somebody spelling out the story about what it takes for something to be green in terms of wavelengths. Well, you're not going to be able to deduce that just from sitting in your armchair. You have got to go out and investigate. The physicists eventually tell us what the relevant wavelengths are and how it is that something can be green. So there's that distinction. But Kant drew another distinction as well. He distinguished between what he called analytic knowledge and what he called synthetic knowledge. Now, analytic knowledge is knowledge that's available just by reflecting on the concepts that are involved. Just thinking about the concepts is already enough to put you in a position to see that the thing is true. Whereas in the case of synthetic knowledge, sheer possession of the concepts is not good enough to be able to tell whether it's true. So an example of analytic knowledge would be all green things are coloured. The same example. I mean, all you need to be able to see that that's true is a grasp of the concept of being green and the concept of being coloured. An example of synthetic knowledge would be anything that's green reflects light of such and such a wavelength. So obviously, I've deliberately used the same two examples because on the face of it, you might well think, well, are these not just two ways of drawing the same distinction? I phrased it slightly differently. In one case, I talked about what you can do in the armchair. In the other case, I talked about what's available to you just by reflecting on the concepts. But is this not in effect two ways of drawing the same distinction? And so one of the things that's very revolutionary about Kant's thought is that he's got these two distinctions where previously people had only operated with one. And he says, no, they're not two ways of drawing the distinction. And in particular, there are examples of knowledge that is a priori, but synthetic. That's the thing that's distinctive about Kant's view. He believed that there is such a thing as a priori synthetic knowledge. So his favorite examples, and the first examples that he gives, are derived from mathematics. And he used examples from arithmetic, and he used examples from geometry as well. So one of his arithmetical examples was 7 plus 5 equals 12. And Kant said, look, this is a priori. You don't need to get out of your armchair to do mathematics. You don't have to go and do experiments. I mean, if you put 7 rabbits together, 7 male rabbits together with 5 female rabbits, it may only be a question of time before you've got more than 12 rabbits. Um, uh, I mean, I'm being facetious, obviously, but you can see the point that I'm making, that this is not an experimental science. We can do mathematics in the armchair, so it's a priori. But, said Kant, it's not analytic. Sheer possession of the concepts is not good enough, actually, to be able to see that this is true. You've got to be thinking somehow about how numbers behave. Or in the case of geometry, one of his examples was between 2 points, there's only one straight line. And Kant said, well, that's a priori. You can deduce that just from your armchair. But again, it's not analytic. Just knowing what it is for a line to be straight doesn't put you in a position to see that this is true. You've got to be thinking about what space is like. Now, before I go any further, I have to emphasize something that will already be obvious to the viewers, I'm sure, which is a lot of this has subsequently been challenged. Kant is taking things for granted that people no longer do take for granted. So there are plenty of philosophers who would want to claim that the arithmetical example is analytic. And there are plenty of philosophers who, for one reason or another, are suspicious of Kant's distinctions. So not everybody these days believes that there is an analytic-synthetic distinction. And in the geometrical case, there's Kant insisting that it's a priori, that between any 2 points there's only one line. But actually, nowadays, we don't think that is true. And physicists have accustomed us to the idea of non-Euclidean geometry. And they have also encouraged us to accept that space itself is non-Euclidean. So there's a lot here that can be criticized, and it can be criticized at a very, very fundamental level. I mean, Kant is taking things for granted that we now know that he shouldn't be taking for granted. But it's often the way with a great philosopher that, even if they're wrong, they're still wrong in a really interesting way. So in order to get the benefit of Kant's philosophy, you have to sort of go along with him, I think, and you have to pretend that he's right. And if he's right, I mean, we now know that he's wrong, but if he's right, we have this puzzle. How is it possible, just sitting in an armchair, to know what space is like? Why don't we have to go out and investigate? Asks Kant. And the only answer that he thought he could give was, well, this must be because space is somehow dependent on us. I mean, it doesn't seem that way. We don't think that space is dependent on us. But Kant was prepared to draw this rather counterintuitive conclusion that space and time as well, for that matter, are a little bit like native spectacles that we carry around with us, that this is how we view things. It's as if we impose a kind of structure onto what we see when we look out at the world. And this structure includes space and time themselves. So it's a very, very, very radical view. And as I say, in many ways, a very counterintuitive view. But that is the view. And he thought that things in space and time were therefore mere appearances. There's this underlying reality that is not spatial and is not temporal, but we can't know what that's like because we can't take our spectacles off. And so this is obviously related back to that fundamental question that I was talking about earlier. What are the scope and the limits of our knowledge? And Kant is now telling us something very fundamental about the scope and the limits of our knowledge. We're limited to knowing what things in space and time are like. And what that means is we're limited to knowing what appearances are like. We can't know how things in themselves are. Sometimes you mentioned the word noumena a little earlier. Sometimes he uses the word noumena when he's talking about things in themselves. And another thing that Kant would say is that we can't know what noumena are like. And this is all very relevant to his ethics because he believes that our freedom is a matter of how we are in reality, not a matter of how we appear. And that's why even our freedom goes beyond the bounds of our knowledge. Because as far as how we appear is concerned, as far as our existence in space and time is concerned, Kant believes that there is no room for freedom because he was writing in the wake of Newton, and he believed that Newtonian science had shown that everything within space and time is completely determined by rigorous physical laws that leave no room for freedom. And again, a lot of this has subsequently been challenged. Kant is very much a product of his time. But my own view is that that doesn't stop it from being deeply, deeply interesting. And actually, it doesn't stop it from being able to teach us something. I mean, you don't have to think that it's all right to believe that we have lessons to learn from it.
Wow, this is fascinating. So, if I understand correctly, Kant says that we view the world and in a certain way because we filter it through the way we experience space and time.
Yeah.
So that brings to us some limitations in our understanding. Am I on the right tracks? Okay.
Definitely, yes. That is right. Yes, yeah.
Okay. I'm aware of time, and I also want to divide our rest of our time onto other topics. So although I have lots of questions to ask you, I'm also really excited to learn about the other two topics. So I want us to slowly do a transition to Kurt Gödel. I know you wrote a book on, and I feel bad because my pronunciation of his name is bad, so you can correct me. It's Kurt. I know how it's written, but how do we pronounce it? Is Gödel, Gödel?
Gödel. I mean, I'm not a
Gödel.
native German speaker, and I may be mispronouncing it actually, but yes. Gödel.
And I already have strong accent as it is. But yeah, I know you wrote a short introduction on him. And I've attempted to understand the basic theory of incompleteness quite a few times, and a lot of charismatic people. There's a lot of lectures from many charismatic people on YouTube, like Roger Penrose and others explaining it. But can you give us an introduction to Kurt Gödel and his theory? Let's see how far off my understanding is.
Sure, yes. So Gödel is a 20th century logician, a brilliant logician, and well known for a number of things, but best known for this particular result, which is referred to as Gödel's theorem. And it's a result about arithmetic. And what I mean by arithmetic in this context is pretty much what most people mean by arithmetic, actually. Arithmetic is concerned with the positive integers, 1, 2, 3, 4, 5, etc. Or sometimes 0 is included, 0, 1, 2, 3, 4, 5, etc. And if 0 is included, then we mustn't talk about the positive integers, but we can talk about the non-negative integers, or sometimes they're referred to as the natural numbers. And arithmetic is concerned with these numbers and the various operations that apply to them, like addition and multiplication. So we were earlier considering a very simple example of an arithmetical truth. 7 plus 5 equals 12. That's a piece of arithmetic, a pretty basic piece of arithmetic. But needless to say, there are arithmetical results that are much more complicated and much more interesting than that. So, for example, it's a theorem of arithmetic that every natural number is the sum of 4 squares. So, for example, 20 is 16 plus 4 plus 0 plus 0. I mean, you can add zeros on at the end if you want to. But that's enough to show that 20 is the sum of 4 squares. And you can prove that every natural number is the sum of 4 squares. But it's a long and complicated proof, and it's much harder to show that than it is to show that 7 plus 5 equals 12. So that's an example of a more interesting result. And there are some questions in arithmetic to which people still don't know the answers. So a very famous example is something that's known as Goldbach's conjecture. The mathematician Goldbach made this conjecture, and the conjecture is that every even number is the sum of 2 primes, or every even number greater than 2 is the sum of 2 primes. So, for example, 8 is 5 plus 3. 16 is whatever it is. I wish I hadn't started this. 11 plus 5. And nobody knows for sure whether Goldbach's conjecture is true or false. There's never been a counterexample discovered to it. But on the other hand, nobody has ever proved it either. So that's an example of an open mathematical question, and there are mathematicians that work on it, trying to see if they can come up with a proof of Goldbach's conjecture. So that's what I mean by arithmetic. Now, when people are working on arithmetic, the way in which mathematicians work is by taking certain basic things for granted and then trying to establish these more complex results on the strength of those basic things. So one thing that will be absolutely taken for granted is that if you multiply any number by 0, the result will be 0. And that's not something that typically a mathematician would feel that they needed to prove. They would think, no, I mean, that's, as it were, just one of the rules of the game. You've got to accept that if you're going to even understand what multiplication is. And then there are various other, fundamental principles of that kind that somebody who's working in arithmetic will take for granted. And so the question arises, can we find a stock of basic principles of that kind, which we know in advance will enable us to do all the arithmetic that we want to do? Can we find some fundamental basic principles that are going to be strong enough to enable us to prove any arithmetical truth without paying the price of also being able to prove some arithmetical falsehoods? We want these basic principles to be strong enough to give us everything that we want, but we don't want them to be so strong that they give us too much. So that's the question. Is there a basic stock of fundamental principles which will capture all and only the truths of arithmetic? Or another way to put it, is there a basic stock of principles which capture the whole truth and nothing but the truth about arithmetic? And we talked earlier about Euclidean geometry. I mentioned geometry in connection with Kant. And one of the reasons that geometry is interesting in this connection is that we know that we can do something like that in the case of geometry. And in fact, over 2,000 years ago, Euclid was already paving the way for this. Exactly what Euclid did was to lay down some basic fundamental principles from which he tried to deduce more and more complicated geometrical results. So his basic principles included one that said that between any 2 points you can draw a straight line, and then the more complicated results that he established included things like Pythagoras' theorem: the square on the hypotenuse is equal to the sum of the squares on the other two sides. Now, in fact, we now know that Euclid's own work wasn't quite as rigorous and comprehensive as it should have been. But even so, what Euclid achieved was remarkable, and it sort of set the standard. And what he was trying to do can be done in the case of geometry. And so the question arises, can it be done in the case of arithmetic? And this is the point at which Gödel's theorem is relevant. And basically, what Gödel's theorem is it's an answer to that question, and it's a negative answer to that question. Gödel showed that it is impossible to derive basic principles that are going to enable you to prove all the truths of arithmetic without enabling you to prove some things that are false as well. You can't strike the balance. Now, I'm glossing over some complications here. Let me say something about one complication that may occur to people straight away. I can imagine somebody coming along and saying, "Well, hold on a sec. Why can't you just let each truth of arithmetic be a basic principle in its own right?" And then you've got a one-line proof of every truth. It serves as a proof of itself. What's to prevent that? And the answer is, Gödel makes clear that he's demanding a bit more of our basic principles, and in particular, to put it intuitively, we've got to have some mechanical way of telling whether something is a basic principle or not. I mean, just telling us that it's a basic principle if it's true is not going to be of any use to us at all. And in particular, of course, that's not going to help us with Goldbach's conjecture. I mean, the whole point is that we don't know whether Goldbach's conjecture is true or not. So coming along and telling us, well, let that be a basic principle as long as it's true, is really not going to be very helpful. So as long as basic principles are the kinds of things that they should be, then Gödel comes along and answers the question and says, no, you cannot do in arithmetic what you can do in geometry. That's the basic result. Does that tie in with how you had understood it?
I think so. So, if I understand correctly, the question is, can we use some fundamental principles / truths and use them as axioms to be able to, and then we'll be able to say, because these things are true, then we can deduct that everything else can be true too. And the answer is no.
That's right. Yes. Yes. I mean, you have just used a word that I didn't use. I kept talking about basic principles, and you used the word axioms. Eventually, there's a rather interesting distinction to be drawn between those, actually. But for these purposes, it does no great harm to think of basic principles as axioms, and let's use the term axioms as well in the way that you did. But yes, I mean, Gödel is telling us that arithmetic cannot be axiomatized.
What's the... Sorry, I'm interrupting you. Tell me.
Yeah, no, carry on. Yeah.
I was just going to ask, what's the broader implications of of this, is there an intersection with this that allows us to make conclusions about how things, and again, this might be a really stupid question, I'm just curious, how things like perhaps you have a super intelligent computer and you're putting it some information and perhaps you put it these principles, maybe, well, I don't know, maybe it can't generate like really advanced things because inconsistencies are going to start appearing, or not. I'm just kind of brainstorming and asking really.
Yeah. Well, you're brainstorming in a really interesting way, and the fact is that people do draw these connections, and in particular, I seem to remember that you mentioned Penrose a little earlier. Penrose, a very famous mathematician who's still alive, actually, although he's pretty elderly now. But he argued that there are some really interesting repercussions of Gödel's theorem that do relate to computation and do have a bearing on human intelligence as well. And in particular, one thing that Penrose wanted to argue was that we can use Gödel's theorem to show that the human mind has capacities that no computer has. Now, this is a really striking result if it does follow. And this is very controversial, but this is certainly what Penrose has argued in the past, and it's something that Penrose still argues vigorously. And roughly, I mean, very, very roughly, the way the argument goes is this. If you've got a computer that's doing arithmetic for you in the way that, little pocket calculators used to, if you've got a computer that's doing arithmetic, it must be operating with some basic principles, some axioms, somehow programmed in. And as long as it's a decent computer, then these axioms are not going to be so strong that it's churning out some falsehoods. As long as it's a good computer that's been decently programmed, it's never going to prove that 7 + 5 is equal to 13, for example. It's not going to make mistakes. But according to Gödel, it may not be making mistakes. There may not be any errors, but there are going to be omissions. There are going to be things that it can't do because its basic principles are not going to be strong enough to enable it to prove every truth. That's what Gödel's theorem shows. So already it looks as if we're able to deduce from Gödel's theorem that there are inherent limitations to what a computer can do. Now, when Penrose first peddled this argument, I mean, this is going back many, many, many years, and it was long before the advent of AI as we know it nowadays. And you might well wonder whether he would be thinking differently if he was familiar with subsequent advances. But at any rate, at the time, and he is, I mean, actually, he is familiar with subsequent advances and he hasn't changed his mind. As far as Penrose is concerned, this argument still has viability. And so we've got this inherent limitation that any computer is subject to if it's going to be trying to do arithmetic. Now, the twist is this. Penrose says, not only that, but what the computer can't do, we can do. So if you consider the computer's program, and if you look at the basic principles that it's been given, there is, in fact, the wherewithal for us to say something about how they should be supplemented. We human beings, can say what we need to do to go beyond these basic principles. Now, whatever we say about that, whatever new principles we introduce, we're still going to be subject to Gödel's theorem. They're still not going to be strong enough to enable us to prove all arithmetical truths. But we can say something about how these principles need to be supplemented. And so Penrose's view was, here's a really striking difference between how the human mind works and how a computer works. And in particular, given any computer that's doing arithmetic, we are always going to be able to outsmart it. That was Penrose's argument. There was another 20th century philosopher called Lucas, who argued for a very, very similar conclusion. And so this is often referred to as the Lucas-Penrose argument. I think it's true to say that they got there independently, but they were arguing along very similar lines. And I mean, it's controversial. There's any number of people that will tell you that the Lucas-Penrose argument is unsuccessful, and there's all sorts of objections to it. But that's the argument, and that ties in with what you were saying about how Gödel's theorem might have really interesting repercussions, and in particular, interesting repercussions for computation.
Interesting. I have lots of questions, and I'm in my head. This is the worst because it's the same thing that happened. I had a podcast with Dr. Barrett on integrated information theory, and we talked about consciousness. And it was the longest podcast I heard. I think it was 3 hours long, and we had a 1 hour lunch break in the middle, which we just continued talking about the same topic. And then by the end of it, I had to go to a lecture, and I'm like, oh God, I have so many questions. But I'm trying to prioritize what I should be asking you in terms of what I find most important and interesting. I was reading Professor Hofstadter's book, Gödel Bach, and I just want to see if I'm understanding correctly. So Gödel came to this conclusion that did he come to this conclusion because within every system we can find some loopholes. For instance, I remember there was that example of, and this is not a direct quote, and perhaps you can correct me, but something along the lines of this statement is false or something like that. That's kind of an inconsistency within a system, and he used that as an example. Am I in the right lines here?
Yes. Yes. You're certainly in the right territory. I mean, so far, all that I have done is state Gödel's theorem, and I've said a little bit about Penrose's reaction and Lucas's reaction, what they think it shows. but I myself haven't done anything so far to indicate how the theorem is proved. How did Gödel establish this result? Now, what you've just done is relevant to the proof of Gödel's theorem. And it's hard to it's hard to know how much detail to go into, actually. I mean, it's one of those cases where you either have to say very little or you have to say a huge amount. And so there is a danger that we would be here for another 3 hours. But maybe I can say a little. In the hope that this isn't just going to be incredibly confusing for the viewers. But one of the things that Gödel did was he said, look, we can assign numbers to arithmetical formulae or to arithmetical statements. I mean, there are various ways of doing this, systematic ways of doing this. But basically, what's going on here is that you're using numbers as a kind of code. So instead of talking about the statement, every natural number is the sum of 4 squares, you might have a code that enables you to assign some massive great number to that statement. And it probably will be a massive great number, actually, because any code is likely to generate very big numbers very quickly. But we can assign numbers to statements. And if we do this, we might find, and Gödel showed that we would find, that sometimes when you're trying to prove things about statements, there is going to be a corresponding proof about the numbers. So, for example, you might be interested in whether one statement follows logically from another. And Gödel showed that if you set things up appropriately, then that's going to be equivalent to asking whether 2 numbers stand in a certain relation to each other, a certain arithmetical relation to each other. I mean, it's not going to be as simple as asking whether 2 numbers add up to 12. It's not going to be as simple as asking whether 7 plus 5 is equal to 12. It's going to be much more complicated than that. But even so, basically, you'll be doing arithmetic. So instead of talking about statements, you find yourself talking about numbers, about natural numbers. Now, the really, really clever thing that Gödel did, and this is mind-blowing, actually. I mean, it's astonishing the way Gödel set things up. But he set things up in such a way that you could find statements of arithmetic which were basically talking about their own number, and so in a funny kind of way talking about themselves. So you've got this statement of arithmetic that's making some claim about, I don't know, 5 trillion and 73. And lo and behold, it turns out that the number that's assigned to this statement is 5 trillion and 73. So you've got this statement that's it's as if it's a statement about itself. And then he went on to show that in particular, you could construct a statement that was in effect saying, I am unprovable given these basic principles. So you've got to imagine that you start off with some basic principles of arithmetic, and then Gödel constructs this statement that says, well, you can't use those basic principles to prove me. And it's able to do this because it's one of those statements that's talking about its own number. And so I am unprovable using these basic principles. Okay, so what that goes to show is that the basic principles have left something out, because you've also got an argument to show that it's not just claiming its own unprovability, but it's true. It had better be true, because if it was false, if it was saying I am unprovable and it was false, then the fact that it's false means that it is provable using those principles. So you could use those principles to prove something that was false, and you don't want to do that. So if the principles are any good, then this is going to be an example of something that's true, but that can't be proved using those principles. Now, that's the 10-minute version. As I say, the alternative would be the 3-hour version, and the 3-hour version still probably wouldn't be enough time. I mean, it's an incredibly sophisticated and elaborate procedure that Gödel goes through. And you know, I mean, as you might imagine, I mean, the cleverness that must be required to find a statement that's talking about its own number.
I want to emphasize on the last part of the podcast on Wittgenstein and the philosophy of language. There's one thing that I don't know if I'm shooting myself on my own feet now by asking this, but with Kurt Gödel's theorem, is there a word where we can find the perfect principles, and then there won't be any inconsistencies, or does every system have this problem, or is it some systems?
Well, one thing that does need to be emphasized, because people very, very, very often get this wrong. We need to emphasize something that I have been trying to emphasize, which is that Gödel's theorem is a result about arithmetic. There are other branches of mathematics, including geometry. I've already mentioned geometry a couple of times, where it is perfectly possible to come up with basic principles that are absolutely perfect. They give you precisely what you want. They give you precisely what you want. They give you as much as you want, but without giving you too much. So Gödel's theorem is specifically about arithmetic, and you will see popular statements of Gödel's theorem that get that wrong, and suggest that this kind of thing is impossible in any branch of mathematics. But as long as you're thinking about arithmetic, then Gödel's theorem really does show the impossibility of an ideal set of basic principles. Now, am I right in thinking that you see a connection with Wittgenstein there? Is that what is that why you asked this question, or was that just finishing off the previous
Oh yeah, no,
conversation?
that was just finishing off. I just
Right.
said that I'm scared to ask this in case this takes us to a half an hour tangent.
Right,
But
right.
I'll ask it anyway because I really wanted to ask. But no, now I understand what you're saying and makes sense. Okay, so let's open a new chapter, being Wittgenstein and the philosophy of language. I'm aware of time, but I think even if you did a nice introduction to this topic for people that may have not come across it, and I think it's good. It's still good, and it's still valuable. And I'm also really interested to learn. So, yeah.
Um, well, if you are interested in a summary of Wittgenstein's philosophy of language, there's one crucial complication that we have to mention straight away, which is that often people talk about the early Wittgenstein and the later Wittgenstein as if these were two different philosophers. Wittgenstein did work early in his life, which he subsequently reacted against. So you have Wittgenstein's early work and you have Wittgenstein's later work, and there are some striking differences between them. There are some very, very interesting similarities as well. I mean, he wasn't by any means rejecting everything, but there are some striking differences, and in particular, there are some striking differences as far as the philosophy of language is concerned. And in his early work, he painted a picture of language whereby if you analyzed the various things that we say, you would eventually find, eventually being the operative word, because this is not obvious on the surface, but you would eventually find that there are, as it were, little bits of language, not necessarily the words that we're familiar with, maybe nothing that appears on the surface at all, but little bits of language that hook up with little bits of reality. And the idea was, Wittgenstein's idea was that when you put those little bits of language together in a certain way, you're saying that the corresponding bits of reality are held together in the same way. And then what you're saying is true if reality is like that, and what you're saying is false if reality is not like that. Now, once again, this is an incredible oversimplification, but there's something along that lines going on in the early work. And Wittgenstein was well aware that not everything that we do with language is a matter of saying things that are true or false. We can, for example, ask questions or give commands means you might tell somebody to close the door, or you might ask them, when is the next train to London? So there are various linguistic things that we can do that don't involve saying things that are true or false. But nevertheless, Wittgenstein thought there was something absolutely fundamental about saying things that are true and false, and this was the story that he wanted to tell about that. Now, in his later work, he became altogether more suspicious of the idea that there is anything that's absolutely fundamental in that way, and certainly suspicious of the idea that saying what's true or false is fundamental in that way. And he was increasingly sensitive to the variety of different things that we do with language. We do say things that are true and false. We do ask questions. We do issue commands. But we do lots and lots and lots of other things as well. So a friend might greet you in the street and wave and just say hi or hello. And that's a perfectly meaningful piece of communication. But they're not saying anything that's true or false. They're not asking you a question. They're not issuing a command. It's a greeting. It's a linguistic move of a quite distinctive kind. And if you stop and have a conversation with them, at the end of the conversation, they might say goodbye. And again, that's a distinctive move. And I'm deliberately using the word move here because one thing that Wittgenstein did in his later work was he talked about various language games that we can play. And he thought that what we were doing was a bit like making moves in a game. And sometimes when you're playing a game, you are literally making linguistic moves. So, for example, if you're playing bridge, some of what you're doing is linguistic. You begin a new game by bidding, and you may bid for no trumps or whatever. That's a distinctive linguistic move within the game of bridge. And Wittgenstein urged us to see all of language as being a bit like that, all the various different moves that you can make, the incredible variety of things that you can do with language. And this is already a departure from the rather narrow theory that he espoused in his early work. And then part and parcel of this is that not only is he encouraging us to look at the variety of different things that we can do with language, but he encourages us to look at language in context, in social context, and to think about the different ways in which we're not just making moves, but interacting with one another and building up a kind of social world where there's very little of that in his early work. In his early work, there's a focus on language where you sometimes get the feeling that he was taking for granted that he was concerned with what one solitary individual might do all on their own. Now that may be unfair to the early Wittgenstein. It may be that he's not thinking in those terms, but there's a great deal of what he says that would be conducive to thinking in those terms. So there's a much more blatant emphasis in the later work on the social dimension of language. Now that's very hurried. I mean, obviously, there's much more to be said. But maybe I can ask you a question, actually, which is, when you asked about Wittgenstein, did you have in mind the later Wittgenstein? Was that what you were thinking of, or were you yourself already thinking about these two phases?
Well, partly, Professor Genia gave an introduction on the podcast I had with her on Wittgenstein, and she talked about the distinction between an earlier and later Wittgenstein. So I found that quite interesting. From what I understand, and please correct me, it seems that in his initial view, words are used to equate to bits in reality, but then he later added to this that also sometimes words do more than that. They don't only represent things in reality, but because we can say a lot of things that aren't necessarily pointing in an object kind of in space or time. And you gave a couple examples, and then you also mentioned that later he emphasized the importance of putting things into context, and to think about the social context, and also thinking about language games. Yeah. Okay. I always like repeating in simple terms what you say, just because I just want to make sure I'm understanding what you're saying, how I'm supposed to.
Yeah.
I'm aware that sorry, please tell me.
I mean, as far as the first point that you're making is concerned, I mean, if you think about a proper name, like Kyriakos, there is a sense in which that's a little bit like a label. You've got a particular person, and you've got a particular name, and that name is standing for that person. And because that name stands for that person, that enables us, that enables the rest of us to talk about you, and or to address you, and so it's very tempting to think, well, maybe all of language is like that. Bits of language standing as labels for bits of reality. But then you think about examples like hello and goodbye, and you quickly realize, no, it's not all like that. If a friend of yours greets you by saying hello, that word is not picking out anything in reality, in the same way that your name, Kyriakos, does pick out something in reality.
I see. This was very fascinating. I apologize because I'm aware that we jumped from topic to topic and we couldn't really go in depth in any of them. But I think still it's useful to just even just having these introductions to these topics, I think, is useful to facilitate my own curiosity to learn more about them, and also the audience's curiosity. We're coming towards the end of the podcast as we're approaching 7 p.m. now. I just wanted to ask you a couple of questions that are closing questions. First of all, how did you find our conversation? Did you enjoy it?
Yes, but I'm afraid that's for the very self-indulgent reason that I like listening to my own voice. But yes, I mean, I'm always in my element when I'm discussing philosophy. So I did enjoy it, and once again, thanks very much for the invitation. I guess what's much more important is to know whether you enjoyed it and whether the audience are likely to enjoy it.
Oh, I'm sure people will find it very interesting. I definitely find it very interesting. Perhaps it's a good idea for me to go and read your book on Gödel and sit down. And I think it's perhaps a book that I should read slowly instead of rushing. Because sometimes I do rush books because I'm excited to go to the next book. Perhaps that might be one that I should go in on a slower pace. The last question I wanted to ask you, which I ask to everyone, is if you had to summarize your life's mission in one sentence, what would that sentence be?
Gosh, that is a tricky one. um, uh, I am a professional philosopher, and that has involved researching philosophy and teaching philosophy. And I suppose it follows that in a way my life's mission has been to nurture and to promote philosophy. Um, I I'm always very conscious when I have this sort of conversation of how lucky and how privileged I am because the fact of the matter is that my profession is also my hobby. I mean, if they didn't pay me to do this is what I would be doing anyway. I thoroughly enjoyed the subject, and I thoroughly enjoyed discussing it with other people. But it has been my profession, and I suppose that's the answer that I would give: the nurturing and promotion of philosophy. And obviously, if there was more time, you could press me on why I thought that it was important to do that.
I just looked at the clock and I'm like, do we have time for this? Probably not. But that might be a question to answer another time. Well, again, thanks so much for having this conversation. I hope you guys enjoyed our conversation, and we'll see you at the next episode. Bye-bye.
Thank you.